Alrighty, and then from section 1.4, we had writing equations and inequalities. So you need to be able to write an equation or inequality given a sentence, and your instructions for that might also say write an open sentence. So that was one of our vocabulary words from that day. And if you see the words open sentence, that just means it's going to be an equation or an inequality. And then you also need to be able to determine whether a given number is a solution to an equation or inequality. So in order to determine that, you pull a Glade and plug it in. Plug it in to check it. So number 7, we're going to do A together. You'll have B for homework. You need to be able to translate the following into an equation or inequality. So the quotient of 6 and a number is at most 15 and at least 2. So first of all, there's a couple keywords that jump out at me. So the quotient of 6 in a number. That is something that we actually learned from section 1.3, where we just have to take, quotient tells us division. Now, since it goes 6 and then a number, that tells us we're taking 6 divided by x or n or q or whatever. You can also write that as a fraction and call it 6 over x. Either is fine. And then we have is at most 15. Well, if that expression, 6 divided by x, is at most 15, if you go back to your vocab and like the list that I gave you at the start of your 1.4 notes, you'll see that at most is going to be less than or equal to. So it's at most 15 and at least 2. So this expression right here is at least 2. Well, at least was greater than or equal to. But since we have, the quotient of 6 in a number is this and this is our clue that this is going to be a compound inequality. So I believe this was our third example from our notes that day. So whenever you've got it's this and this, you flip the inequality and you put your other number first. So we start with 2, and then we have 2 is, if we were going to have greater than or equal to, when we flip it, it becomes less than or equal to. So we really have 2 is less than or equal to 6 over x, which is less than or equal to 15. So that keyword and was really the one that told us that we had a compound inequality. Then for number 8, determine whether x equals 17 is a solution to the equation or inequality. Well, if we are asked to check whether it's a solution or not, we pull a Glade and plug it in. So we've got 2 times 17 minus 4 is equal to, 26, and then we have to simplify using order of operations. So next comes our parentheses. 17 minus 4 is 13. Is 2 times 13 equal to 26? It is. 26 is equal to 26. So yes, x equals 17 is a solution to that particular equation. So then for 8b, you're going to plug it in and find out if it is greater than or equal to 0. Then from section 1.5, we used our problem solving plans. So that might involve just a problem solving strategy to solve an application problem, or you might be asked to solve using a formula. And notice it says given formulas. So just like your quiz, you'll be given all of the formulas, you just won't be told what each one would be used for. So you have to know what those variables stand for. So in number 9a, we'll do that together. Bill goes to see a movie that starts at 2 p.m. And then when it's over, he decides to see a second movie. And the second movie starts right after the first one. And it's the same length as the first one. Bill has to be home by 7, and he lives 20 minutes away from the movie theater. Determine if he can see a 120-minute movie. There's 2 different ways that you could probably solve this one. If you're an equation person or an inequality person and you want to write an equation or inequality, be my guest. I am more of a, well, let's just kind of think it through kind of person. So we want to know if he can see a 120-minute movie. Well, we know he's starting at 2 p.m., so it's 2 o'clock. And he sees 2 movies that starts right out, and the second one starts right after the first one, and it's the same length. So one movie is 120 minutes. Well, 120 minutes divided by 60, that's a 2-hour long movie. So if he sees one movie, then all of a sudden it's going to be 4 p.m., 2 hours after that movie started. Well, and then the second movie, it's going to be 2 hours after that. So that's going to be 6 p.m. He needs to be home by 7, and he lives 20 minutes away. Well, if he lives 20 minutes away and the movie got over at 6, 20 minutes after that is 6:20. Is that before 7 p.m.? Yeah, absolutely. So he's good to go. Now, if you wanted to write your inequality, what it would end up looking like would be, okay, it's 2 o'clock to start with, plus we said those movies were 2 hours long, and he's seeing 2 movies, so that's where this 2 is coming from. And then X is the length of the movie in minutes. And then plus his 20-minute commute, but everything's in hours right now. So 20 minutes is a third of an hour. And that needs to be less than or equal to 7 p.m. So then we could test X equals 120 minutes or 2 hours, whichever. But either way, we're going to find out, yep, he sure can see that movie. So your job, for example, or problem number 9B, is to figure out first the expression for the total cost of the ingredients. So this one's going to have 2 answers. So you write the expression and then find the total cost of this many tomatoes and this many peppers. So make sure you answer both parts.